with Alan Turing in this. Okay, Bismillah ar-Rahman ar-Rahim. So I said, let us see these 8 things. What is the first thing? Computability. What is second? This is the church, Alonzo Church, and this is the Turing, and together their thesis. Third thing is decidability or decidable. Is the problem decidable or not? Is the problem undecidable? Is the problem partially decidable? Number 6, recursive problems, and we have recursively enumerable. These look like, oh my god, what terms, but they are nothing. Recognizable. These 8 terms, we go, you understand each of all them, right? So first thing first is, what is computable? What is? So what is computable is what Turing thesis is all about. There are 2 scientists. One is the Alonzo Church, 903 to 1990. But look at this guy. This is the teacher, this is the student. The student, 1912 to 1954, he was died or he was killed, I don't know. You search about yourself. But he was a great person. This guy gives us the lambda function. And he say that in general, or this guy gave the Turing machine. This guy gave what? This was the mathematician, so also the mathematician. Let us talk about more about, because this guy actually, this was a teacher and this was a student. He was a student and he gave the lambda function, thesis, his research paper. He said that all the problems we can have, we can solve them using these functions, using a lambda function. You can solve that using a lambda function. And if it is solved with a lambda function, it is computable. Right? And this guy gives the same thing, but he called it Turing machine. But he was more formal. Both of them give the research papers, and this guy was more formal. Basically, the Alan Turing, he was very genius, he was very interested in science and all and everything. Then he said that when we think, he was trying to interpret the brain. That when we think, and he was trying to convert that into mathematical model. He was trying to do all the thinking. He treated our brain as a machine. And he gave the mathematical model, which was the input and output. This is how our brain do, what our brain do. And then this mathematical model, which Turing machine was, abstract machine, became actual computers. Right? But he was actually a secret agent. His work was secret. It was not coming to the world. That is why he was convicted for some crime, whatever at that time that was a crime in the London, in the England, that it was some particular thing was considered, you read about yourself, was considered as a crime. And he was convicted at that time. Right now it's not a crime there. So he was convicted for that, but people didn't know his work because he was actually a secret agent. He saved his country from the World War II. When the World War II happened, the Germany, the Nazis, they were having submarines. And they were sending their codes, how to attack, where to attack, what to put the missile into, right? Like encrypted messages. He was the guy who decrypted them. He worked on that, he decrypted them. But he was a secret agent. His work was not known at that time. Right? After he died, after eating an apple which was injected with cyanide, he died. He had to go for hormonal therapy and all as a punishment. Later on, after his work come into the world, and the world recognized him, that this is the guy, man, who actually started the computers, computer science and everything, the artificial intelligence and everything, right? Actually, this guy was the, this guy was the guy who was thinking. He was such a man that when he was going, he was very athletic, he was very athletic, he was a runner basically. And जब इसको जाना होता था ना ऑफिस, he used his bike, उसको चेन उतरती थी. क्या उतरती? चेन, यानी कि पैडल होते हैं ना, पहले चेन हाफ उतरती है ना, फिर पूरा घुमाओगे तो पूरी उतरेगी. He was a guy, he didn't fix the chain. He calculated कि कितने पैडल्स के बाद मेरे को चेन उतरती है. Say for example 50 पैडल्स के बाद चेन उतर रही है. ये 49 पैडल के ऊपर जब ये हाफ से लगे ना, फिर वापस लगा रहता था ताकि चेन को वापस आए. Right? He was that kind of a guy. And he actually decoded the brain. He was trying to create a machine which works like a brain. And that's what computer is all about. That's what AI is all about today, right? There's a long story about it, and we forgot about these 8 then. So, what this guy gave or this guy gave is ultimately a single thing. Then what is computable? What is this thing, the computable? And they say that a problem is computable if if there is a Turing machine, for example, and say for example we say that if there is some problem, and we can design a solution for it, right? So question is, can we design a solution for it or can't we design a solution for it? 2 things, right? We want to go to America, we can design a solution for it. We want to see God, that we can't design a solution for it. So problem can be computable or non-computable. So if there is a physical mean, that means in our terms, if we can create an algorithm to solve a problem, we have a problem and we can have an algorithm to solve it, or there are some physical means we can do it to for example, I want to go from here to Delhi. I can do that. I can have some aeroplane or do something, right? There's a physical means to do that, right? Or in our case, in computer science, say, if we can design an algorithm to solve a problem, right, then we can have a Turing machine which will solve it. That means if certain things in a world can have an algorithm, then there is a Turing machine which can solve that. If a Turing machine cannot solve a problem, okay, then we can't have. Now, for example, in today's world, we can say we have this problem and we have this solution and Turing machine cannot solve it, right? It's not happening yet. Any problem you have is solved by the Turing machine. Any problem you have is solved by the... So this is what technically we call as what? Turing thesis. Got it? This is Turing machine. Now, I don't know, just see the definition from the internet, right? Just get the definition from the book and write it. That in totality we are saying, what is Turing thesis? That if you have a problem, okay, it has to be, if there is a problem and there is an algorithm for it, then it has to be recognized by what? A Turing machine. So there is nothing which cannot be solved by Turing machine, जिसका solution already हमारे पास है. ठीक है? If we have a problem, it has a solution, then Turing machine, we have a Turing machine which can solve it. Right? So alternatively, there is a Turing machine which will say whether this problem is computable or non-computable. Getting? So there is a Turing machine. If that problem is solvable in terms of algorithm or in terms of mechanical means, then we have a Turing machine for that which can solve it. If Turing machine cannot solve anything, that cannot have an algorithm. Got it? यानी कि फिर उसका algorithm, जैसे मैं कहूँगा कि I want to see the God. There is no Turing machine for that. That means it cannot be solved practically. Because in Turing machine we do it in abstract. We do not, for example, मैंने एक program किया, मैं दूंगा ये input क्या ये solve करके देगा, तो मुझे वहाँ चलाना पड़ेगा ना computer पे, फिर देखना पड़ेगा. But here we are using an abstract machine. We are using what? As a Turing machine. If Turing machine cannot solve a particular problem, that means that problem will not have any algorithm. You getting the point? Just check the definition from the book and write it. So you got the Turing this thesis. Now we have what is called as decidable versus. Now we have a problem. It can be decide or partially decidable, or can we have a blank here? What is it? This is it editable or not? What? नहीं इसका ना ये I want one okay. Now this one. No. Where is the, if I want to add slide to it, huh? It is uneditable, right? Whatever. Where is delete button? Okay. Now, if we have a problem that can be decidable or partially decidable or undecidable, right? It is like here we have the finite automata, then we have what? So we have the regular grammar for finite automata, then we have the context-free grammar. After that, we have a Turing machines. There are two types. Either they are decidable and they are partially decidable, and then we have one more which is undecidable. These two guys gonna shoot the Turing machine. These two guys gonna shoot the Turing machine, which is decidable and partially decidable. So what does the decidable mean and what does partially decidable mean? Do you understand? Let us try to work on this now. And then what is undecidable? The first thing is decidable. Why the decidable comes? We have the regular grammar, okay, then we have the context-free grammar, and then we have the decidable here. Undecidable comes, partially decidable comes here, and undecidable comes on top. Undecidable means it cannot be computed, it is not computed, though we don't have a Turing machine to actually solve it. But if it is decidable, what does it mean? Now, decidable is also called as recursive grammar, or we can have recursive language here. So, जो next हमारी term थी recursive, and if we have partially decidable, it's called recursively enumerable. So, partially decidable is also called as recursively. Decidable is also called as solvable, computable, or we have the recursive grammar, or we could have recursive grammar. So creating the recursive languages. So these all names same to be same. Now what does it mean? And what's the difference between decidable and partially decidable? So what is the difference between recursively decidable, which is also called as solvable, also called as computable, also called as recursive? Okay? And what is the difference between this and what is the partially decidable? Because next is partially decidable is also called as recursively enumerable, and it's also called as recognizable. So if some problem comes here, so this is a recognizable Turing machine. Okay? A problem which belongs to the partially decidable is also called as recognizable. What is it called? So this guy is also called as recognizable Turing machine. and this guy is called as decidable. Or in terms of recursive and recursively enumerable, this is also called as recursive, and Turing machine this is called as recursively enumerable. तो ये एक ही के अलग अलग नाम है. समझ में आई बात? That's why I told you it takes little time to explain. And now we need to understand what is the difference. लेकिन पहले याद रहा. So what is decidable is also called solvable. It's also called as computable. It's also called as recursive के टाइप में क्या होगा? Recursive और recursive enumerable. Recursive, right? But if it is partially decidable, we can call it what? Recursively, also called as recognizable. याद रहा? Okay. So decidable और partially decidable मतलब क्या है? अब हमारे ये समझना है, ठीक है? हमारे पास एक मशीन है. We have a Turing machine. We have what? और मेरी एक कुछ प्रॉब्लम है. I have a problem and I give it to the Turing machine. Right? For example, मैंने परसों बनाए थे, हमने बनाया था ना, हमने बनाया था ये जिसमें एक्सेप्टिंग स्टेट आ रहा था यहाँ पे and all that, right? मैंने एक लैंग्वेज को दी 101, जिसे हमने पैलेंड्रोम किया था ना, इवन पैलेंड्रोम किया था. मैंने इसको दिया 1001 फॉर एग्जाम्पल, है ना. अगर मैं 100 पढ़ूंगा, यहां से भी 1001 पढ़ूंगा. If I give it to this, what will happen? What will happen if I give it to this? जो ना मैंने बनाया था वो स्टेट डायग्राम, it will accept it. Okay? Will it halt? Yes. ये रुकेगा ना लास्ट में, ये रुक जाएगा और ये एक्सेप्ट हो जाएगा. उसके बगैर अगर मैंने इसको ये लैंग्वेज दी, कोई और लैंग्वेज दी, अब इसमें कितनी चीजें हो सकती हैं इस मशीन के साथ. मैंने हाँ, या तो एक्सेप्ट हो गया, या तो रिजेक्ट हो गया, या और भी एक चीज हो सकता है. हाँ, जोर से बोलो. डेड स्टेट. तो डेड स्टेट में क्या होता है? जैसे मैंने कहा था कि अगर यहां पे जीरोज आ गए, एक्स्ट्रा जीरोज आ गए, फिर ये उधर नहीं जा पाएगा, ये इधर ही फंसेगा. तो ये फंसेगा मगर किस में? लूप में. दिस लूप कुड बी इनफाइनाइट, है ना. कभी कभार लूप लंबी चल के फिर से रुकेगा, फिर ये रुकेगा. कभी लूप में इनफिनाइट फंसेगा ना. तो हमारे पास जो है यहां पे कि एक प्रॉब्लम थी. क्या थी? We have a problem. It halts and accepts. ठीक है ना. जब मैंने ट्यूरिंग मशीन को दिया ये प्रॉब्लम, ट्यूरिंग मशीन को मैंने ये प्रॉब्लम दी, the Turing machine halts and or it halts and, ठीक है. अगर ये दो चीजें हुई और लूप नहीं हुआ, लूप, तो ये डिसाइडेबल है. तो ये ट्यूरिंग मशीन क्या है? सो दिस ट्यूरिंग मशीन इज डिसाइडेबल. दिस ट्यूरिंग मशीन विल ऑल्सो बी कॉल्ड एज रिकर्सिव. So we are using recursive functions. What is a recursive function then, or what will they do? Or recursive machine or recursive Turing machine do? That it will halt in any case. It will halt in, but it can halt by accepting. यानी कि जो आपने, so this will be in a technically if we write it that we have a language L, okay, and in this we have a string W. We have string what? If W belongs to L, if string W belongs to L, then it will halt and accept. If W do not belong to L, it will halt again. But if these two things happen, we call it as the decidable, or we call it as the recursive. We call it what? Getting? But if now the things happen like this, that we have a W belongs to L, okay, so it will halt and accept. W do not belongs to L. For it we have two things. If W do not belong to L, We have for this what? It will halt and reject, or it will not halt. It will not, but loop. It is testing. It's not coming out of it. It's testing. ठीक है? आपने इनपुट ऐसा दिया कि ये टेस्ट हो रहा है, क्या कर रहा है, लेकिन ये इन्फिनाइट टेस्ट में चला गया. फॉर एग्जाम्पल मैं बोलूंगा कल बारिश होगी. आई एम गिविंग दिस, इज टुमारो गोना बी रेनिंग और नॉट, राइट? आई एम गिविंग इट टू द व्हाट, द ट्यूरिंग मशीन. ट्यूरिंग मशीन स्टार्ट्स टेस्टिंग इट. जब तक टुमारो हो गया, टुमारो खत्म हो गया, टुमारो इज ऑफ, व्हाट विल हैपन? इट कम्स, इट halts एंड रिजेक्ट्स. इट halts एंड, कल धूप निकली. अगर कल बारिश हो गई, इट halts एंड एक्सेप्ट्स, हाँ बारिश हो गई. अब मैं बोलूंगा इसको क्या कयामत हो गई, क्या बोलूंगा? इज इट अ डूम्सडे? आई एम सेइंग द क्वेश्चन, इट इज ए, will it halt? It will never halt, na? It will loop forever. Because doomsday, we don't know, it's never coming, na? It's doing it, computing. It's all the time testing. Is it doomsday? Is it doomsday? Is it doomsday? It is in a loop forever. So it is happening in a loop. But we can't say ki it's not computable. One day can come when it's a doomsday. Right? Getting my point? Problem? But can we say, for example, this in terms of God? Can you see the God like this? Or something which is not computable? That problem will be called undecidable. That will be called what? Getting? Yawning? Is it a boring lecture? You got all the points? So I gave you 8 points. I gave you what? Now tell me, the first thing was computable. So anything is computable if we have a Turing machine for that. That is why, what is your church? Turing thesis is. What is this church? The temple? It's the Alonzo church, right? The teacher of Alan Turing, who gave the lambda function and said it's a lambda function. अगर इससे आपका solve हो गया तो हो गया. इसके बगैर कुछ हो. This is still true. This is what? But we cannot have a formal, because this is not a formal mathematical model for this Alan Turing thesis, because this is not a formal way of saying something. This is just a statement that we are saying कि अगर कोई problem है तो then we have a Turing, अगर कोई solvable problem है then we have Turing machine. That means in other words, Turing machine is which can solve any damn thing, whatever you have. ऐसी कोई problem ही नहीं है जो कंप्यूटर solve करता है और Turing machine नहीं solve करेगी. या ऐसी कोई प्रॉब्लम नहीं है कि इसका एल्गोरिथम होगा और ट्यूरिंग मशीन उसको सॉल्व नहीं कर पाएगी. अभी तक ये बात ठीक चल रही है. अभी तक हमारे पास ऐसा कोई एल्गोरिथम ऐसा नहीं है कि हमने क्या किया कि हमने उसका एल्गोरिथम बनाया और ट्यूरिंग मशीन उसको नहीं कर पा रही है. ट्यूरिंग मशीन जो कर पा रही है वही एल्गोरिथम कर पा रही है. ठीक है? इवन वी डिड अ डिफरेंट वेरिएशंस टू ट्यूरिंग मशीन. ट्यूरिंग मशीन में हमारे पास क्या था? टेप, है ना? बिगिनिंग में टेप था और फिर एंड इन्फिनाइट था. We tried different tape, which is in the beginning infinite and in the end infinite. We tried multiple tapes. We tried non-determinism. We tried what? जो आपका Turing machine है ना, remember all the time it is deterministic. It is what? Turing machine is always deterministic. We tried non-determinism in it, but we failed to improve that we can solve some other problems. For example, we thought maybe by using the multiple tapes, by using heads at a multiple positions, by using the double-ended tape, not tape from this side also, in fact this side also, we thought we can use a different sort of language which can be accepted by them. But then we said no, Turing machine is enough. Turing machine solves every damn thing. So there is no need of improvement, variation of the TM. Getting? So that is the Turing thesis. That any damn problem which can be solved, we have a Turing machine for that. So Turing machine solves every damn thing which is solvable, which is computable, which is decidable. Right? Now depending upon कि क्या ये loop में चला जाएगा या इसका halt हो जाएगा in terms of rejection and exception. we have two variations. We have what? Of Turing machine. What is that? अगर आपका ट्यूरिंग मशीन जो आपकी है इसने एक्सेप्ट किया किसी चीज को, तो ये तो हार्ड तो होगा ही ना, तभी जाके तो एक्सेप्ट किया. ये रिजेक्ट भी कर सकती है. इट इज रिजेक्टिंग सम वी से दिस लैंग्वेज डजंट बिलोंग टू द, जो आपने ये स्ट्रिंग दी डजंट बिलोंग टू लैंग्वेज. मैं आपको बोल रहा था कि इवन पैलेंड्रोम दो और आपने दे दिया 00110000. ये इवन पैलेंड्रोम नहीं है. सो दिस विल बी रिजेक्टेड. दिस विल बी, अगर आपने इवन पैलेंड्रोम दिया 0110, मैंने क्या गलत किया, 10 लाइक दिस, राइट? तो 01100110, दिस इज इवन पैलेंड्रोम. मैंने ये दे दिया, ये एक्सेप्ट हो गया. बोथ केस में हार्ड हो गया ना. लेकिन ये हो गया डिसाइडेबल. ये क्या हो गया? ये कौन सी लैंग्वेज हो गई? रिकर्सिव. ये हो गई. अब अगर आपने ऐसा कुछ इनपुट दिया जिसपे इसने लूप मारा, इट इज पार्शियली डिसाइडेबल. क्यों? क्योंकि लूप में कभी ये हार्ड भी हो सकते हैं, लेकिन कभी मतलब ऐसा जो ये पार्शियल डिसाइडेबल है, इसमें कभी एक्सेप्ट भी करता है, कभी रिजेक्ट भी करता है, लेकिन कभी लूप में भी जाता है. एक इनपुट पे इसने एक्सेप्ट किया, दूसरे इनपुट पे इसने क्या किया? रिजेक्ट किया, किसी और इनपुट पे इसने लूप में चला गया. ऐसी प्रॉब्लम्स को, ऐसी लैंग्वेज को हम बोलेंगे रिकर्सिवली इन्यूमरेबल. एंड दिस विल कम इन डिसाइडेबल और पार्शियल डिसाइडेबल. पार्शियल डिसाइडेबल वो ऊपर है. सो ट्यूरिंग मशीन के दो है, डिसाइडेबल, पार्शियल डिसाइडेबल. डिसाइडेबल इज आल्सो कॉल्ड एज रिकर्सिव. पार्शियल डिसाइडेबल आल्सो कॉल्ड एज रिकर्सिवली इन्यूमरेबल. रिकर्सिवली इन्यूमरेबल में एक्स्ट्रा चीज क्या है? लूप में फंस जाना. ठीक है, लूप में निकल के लूप में फंस जाना. बात समझ आई? अगर लूप नहीं है, एक्सेप्ट रिजेक्ट हो गया, हार्ड हो गया, तो ये डिसाइडेबल है. सिंपल है ना. अगर एक्सेप्ट हार्ड हो गया ना, बोथ केस में आइदर एक्सेप्ट और, लेकिन एक्सेप्ट हो गया, या रिजेक्ट हो गया लेकिन हार्ड हो गया, ये चल नहीं रहा, लूप चल, अगर कुछ देर लूप चलाई भी लेकिन फिर हार्ड हो गया, एक्सेप्ट रिजेक्ट कर रहा है, तो ये डिसाइडेबल है, ये रिकर्सिव है. ठीक है. अगर किसी इनपुट पे हार्ड होके रिजेक्ट हो गया और हार्ड होके एक्सेप्ट हो गया, लेकिन किसी इनपुट पे ये लूप में जा रहा है, तो दैट विल बी कॉल्ड एज partially decidable or recursively also called as recognizable TM. It's also called as recognizable. बात समझ आई? हाँ जी, that's it. Okay.